Okay, so I'm recording now. All right, let me do this. Okay, so here what we're going to look at are square roots. Okay, now, so we're going to review basically in this section what a square root is. You know, you probably have seen it before. If you don't remember, that's fine. We're also going to see how to simplify a square root. You'll see what I mean, though. And we're also going to see how to rationalize the denominator of a fraction. It is something I think that's good to know. It could come up when we're doing trigonometry near the very end of the course. Not only that, I mean, originally I started doing it because I started going through rationalizing the denominator of a fraction when I taught this course with my math lab, because it made the students, it made you guys simplify your answers. And part of that simplification was rationalizing. Now, I'm using Lumen Learning, and I don't think you have to simplify your answers. But again, I still think it's good to know. The book, you know, this is P6 in the textbook. They do a lot more in this section than what I'm doing. They do other roots, like the cube root. I think they do in general the nth root, which is a generalization of a square root. But I'm only going to focus on the square roots for time consideration. Okay, so again, the lecture notes are posted already. So let's keep going. So of course, we have to wonder, you know, what is a square root, right? What is it, you know, what is a square root? Well, this is the definition here. We say the number b is a square root of a. Sorry, we say b is a square root of a by definition if b squared equals a. So b is a square root of a if b squared equals a. Okay, that's the definition. Okay, so let's see some examples. Well, we have this one, for instance. We have 3 is a square root of 9. And why is that? Well, because 3 squared equals 9. So 3 is a square root of 9. And yes, there's another one as well. What's the other one? Well, by our sap and sun rules, we have -3 is a square root of 9. And again, that's because -3 squared is, okay. And so we have another example here. 5 is a square root of 25. Okay, that's good. And why is that? Well, again, that's because 5 squared is 25. You know, 5 squared meaning 5 times itself. And so -5 is also, again, by our sap and sun rules. So 25 has 2 square roots. Now, since there are 2, we want to somehow be able to distinguish between them. Okay, so how do we do that? Well, that's where the next terminology comes into play, and notation as well. The square root of a number, and that's what this is. We say b is the square root. I know technically it's the principal square root, but I think most people say the square root. So it's the square root of a if not only it's a square root of a, but also if it's non-negative. So it's a square root of a, as you can see, and it's also non-negative. This is the notation we use for the square root of a. This is a notation we use for the square root of a, this little radical notation. So if this is a square root of a, right, what's the other one? Well, if we went back to the previous examples, right, based on this, one square root was of 9, let's say, was 3, right? The other one was -3. For 25, 5 was a square root, right? The other one was -5. So the other square root is this. It's negative that, as you can see. So it's negative this. This is the other square root. This is the square root, the one that's non-negative. This is the other one. And let me just say this also. Let me just say this. It will come up again. If you square a number, you have to get something that's either 0 or positive. So you have to get something that's non-negative. And that tells us A here has to be non-negative. In other words, you can only take the square root of something that's non-negative, right? If you take the square root of a negative number, that's when you go into complex numbers. I mean, we might get to that in this course. We'll see, though. But here are some examples. So the square root of 9 is 3. And we saw that already. 3 is non-negative. And 3 squared is 9. Square root of 16 is 4, right? And that's because 4 is non-negative. And I forgot to put the square root sign in again, the square sign. And also because, oh boy, let me fix that. And because 4 squared is 16. Same thing with 5. Same thing with 5, right? 5 is non-negative, and 5 squared is 16. Excuse me, 25. So these are just some examples with this notation. That radical thing, the square root, okay? It's the square root that's non-negative. Okay, so that's what we have here. All right. So let's keep going. We'll see some more examples. But before we get to more examples, I just restated this for emphasis. I mean, maybe I didn't have to because the lecture notes are provided, but I feel better restating it anyway. So again, the square root of something is the non-negative square root. That's all. And this symbol here, right, almost looks like a check mark. This is what they call a radical sign. This is called a radical sign. And what you're taking the square root of, so in this case, the A, what you're taking the square root of, that's called the radicand. This is just terminology people use, so it's vocabulary for us. So this symbol here, okay, is a radical sign, and what's under it, number or expression, is the radicand. Okay, so here's some more examples. We have the square root of 121, right? That's 11. And why is that? Well, because 11 squared is 121. And again, also 11 is non-negative. That's why this notation makes sense. Whereas in this line, it doesn't. It's not -6. Well, it can't be negative because by definition, this has to be non-negative. I mean, yes, if you square -6, you get 36. However, this has to be greater than or equal to 0, and -6 is not. So the bottom one is the correct notation. Square root of 36, right? That's going to be 6. Again, 6 squared is 36, but 6 is also non-negative. And this is just what I was trying to say before. You can only take the square root of something that's non-negative. In other words, this A here, called the radicand, can only be positive or 0. And again, I'll say it again. If you allow A here to be negative, then you run into complex numbers. Okay? That's what happens. Okay? Good. Okay, so that's what we have here. Good. Okay, so we have some properties of square roots, some more properties, I should say. For instance, the square root of 225, right? That's going to be 15, okay? And again, why is that? Because 15 squared is 225, and 15, as we know, is non-negative. Okay? Now, but now notice, since 15 squared is 225, that tells us if we replace it in the radicand, so if we take 225, replace it with 15 squared here, we get this. Likewise, if you go back to 36, right? 36 is 6 squared. So if we replace it, we get this equation. And so we get this. What am I trying to say? I'm trying to say that this equality holds. Namely, for any non-negative number, if you square it, then take the square root, you get the number itself back. You get the number itself back. That's what happens here. Okay, let me just pause the recording. Okay, let me just pause.